Well, hello, Merry Christmas! This is the final video in my Advent calendar, and it's a special one because today is Christmas, and I'm really going to talk about two main things. So first of all, I'm going to talk about the wonderful gifts that we've got this year. 2012 has been a fantastic year for particle physics. Right, so the biggest news of course is the Higgs boson discovery. So at this point I'm quite confident in saying we've discovered a new particle and it is a Higgs boson. And there's a small amount of wiggle room because it could be something beyond the standard model, but at this point I think it's pretty much clear that the standard model Higgs boson is the most likely scenario. So we'll see an update in Mariond, but I would not expect any major surprises there. Some of the other big news we've had this year is that the Sesame Experiment measured one of the neutrino mixing angles, theta 1,3. And this is an incredibly important angle because if this turns out to be non-zero, then that means we can have a CP violating phase in the neutrino sector, and that means we can have another source of matter-antimatter asymmetry in the universe. So this angle was measured, and it was measured to be quite large and different from zero, and that means that the next generation of neutrino detectors can start to look at the CP violating effects and the matter-antimatter asymmetries that will imply in the neutrino sector. So that is going to be wonderful. The next couple of decades for neutrino research is going to be incredibly exciting. Some of the other great news we've had has come from LHCb. They've discovered D0 mixing with, I think it was over 9 sigma, so this is definitive evidence from a single experiment, and that's the first time that's happened, and that means that we have seen mixing in every sector which we expect to see mixing in the mesons. We've also seen the B sub S to mu mu measurement from LHCb. We expect an update for that measurement at Mariond, which will get an even more precise result, but it basically came out where we expected for the standard model, and this is a search that has been going on since 1987, so about 25 years, and it's a smoking gun for lots of supersymmetric models. So the fact that it's standard model is a bit disappointing for those theorists, but it has been a long awaited result and we have finally seen it, which has been great news. We've also had news from the B factories. From Bar we've seen the measurement of B to D tau nu and B to D star tau nu, and these disagree with the standard model predictions. Now, the next simplest models also disagree with these measurements, so it'll be very interesting to see what kind of models actually incorporate these and what kinds of predictions they're going to make for heavy flavour. In addition to that, Barbar's also seen T violation, which has shown a huge deviation from zero. And this was actually expected, given that we've already seen CP violation, but this is the first time we've seen T violation independent of the CP violating effects. Now, if you've been reading my blog for a while, you might remember a post where I said that I bet one of my friends $20 that we wouldn't discover the Higgs boson by 2020. Well, here's my $20, and hopefully quite soon I'll be giving this up because we'll have the Higgs boson. Now, the point of the bet, of course, was not that I thought we wouldn't find the Higgs boson. I didn't really have much of an opinion at the time. The point was that we had no evidence for a Higgs boson. And so as a scientist I had to say, well, I have no confidence that it exists. You've got to prove that this thing exists. We now have a lot of evidence that something like the standard model Higgs boson exists. Once we see this boson decay to tau tau and BB bar, then I'll be very confident that there is a standard model Higgs, and I'll be happy to part with $20 for a discovery like that. If we don't see tau tau and we don't see BB bar by Mariond, then it looks like it's not the standard model Higgs after all. And that means that we get Higgs boson, we get new physics, I get to keep my $20. So there's about 3 months left. So Wells, if you're watching and you want your $20, all you've got to do is send me the papers that show Higgs decaying to tau tau and Higgs decaying to BB bar. And now I want to finish this series on a slightly different note. The final thing I want to talk about isn't actually physics at all. It's about an experiment called the Sesame synchrotron. And this is an experiment that's been developed in the Middle East. It's got contributions from many different nations. So for example, it has contributions from Iran and from Israel, and it's basically started to unite the scientists in the Middle East. Now, these scientists don't really have much of a division between them. They have a lot more in common than they have differences between them. They're looking for an unbiased picture of the world, they're looking for an objective truth, and they're looking to collaborate because they know that they cannot get the answers they need and the answers they want if they cannot work together, if they can't reach across these political and social divides that are affecting the world around them. So it's really refreshing and heartwarming to see these scientists come together and say, well, what really matters is what we have in common. It's our humanity and it's our strive to better ourselves. So I'm going to place links to some articles about the Sesame Experiment in the description, so please check those out. It's a wonderful example of people putting political, cultural and religious differences aside and saying this is what matters. This is the truth that matters. This is scientific advance, this is knowledge, this is making ourselves better people, and this is making the human race better, more well informed. Science has a wonderful unifying spirit to it. People from all over the world come together, united by things that transcend national differences. So this is a very heartwarming story for me, and it gives me a lot of hope for the future, that our children and our children's children will find more ways to unite than to divide, and they'll find more in common with each other and make the world a better place by working together and learning together. Have a Merry Christmas.